Hey everybody, in this video we want to solve problem number 32, longest valid parentheses. So the problem is, given a string that consists of only open and close parentheses, we want to find the length of the longest valid or well-formed parentheses substring. For example, here as you can see, these two parentheses are already valid, so that means for a given open parenthesis, it is already, we have a closing well-formed parenthesis for each of them. But here in the second example, as you can see, starting the string, we have a closed parenthesis which is not valid because we expect to see a closed parenthesis for every open parenthesis. So this is not valid, but after that, these four are valid, and then this closing parenthesis also doesn't have any opening, so this will be dropped, and 4 characters is the maximum length of a valid well-formed string. So in order to solve this problem, I wanna explain, let's first simplify the problem. So parenthesis validation is a very common problem which for most of them you can use stack. So let's say instead of the problem that we have here to find the length of the maximum well form, let's say given a string with only characters open and close parentheses, we want to see if the string itself is valid or not. So for that, we could use stack, and then let's say take this example here. So we have a stack, and then we put the characters that we see from on the stack. So as long as they are open, so we just put them. And as soon as we see a closing parenthesis, we just remove the top element. So that means for a given open parenthesis, as soon as we see a closing parenthesis, so we will remove them or we match them together. And at the end of the string, we expect to see our stack empty. So that means all of the parentheses are already matched and the string is valid. Otherwise, as the example that we have here, since we have one leftover character, so that means the stack is not valid. Similarly, in this problem, let's say we have a stack, but instead here, since the problem is to find the longest, the length of the longest value. So let's say in the stack, we store 2 items: the index of the last non-valid index, some index, and the character. So similarly, we in the previous problem that I explained, we only stored the string themselves, just open and closing characters. But here, instead, this is the index of the last non-valid string. So let's define it here. Stack contains inc I index of last non-valid string and c characters. And then we want to iterate through the string itself by knowing for the index and character in enumerate s. So the enumerate function is similarly, we can take a for loop in the length of that by just having I and then assign c to each I. But by using this enumerate, we can directly access to the character itself and the index of that character. So if the character is a closing string, closing parenthesis, and the length of our stack is less than 0, greater than 0. This is the stack is not empty, and the last element, the top of the stack, we expect to see the last element, and for the character is 1. If this is an opening parenthesis, so that means if the current character is a closing parenthesis and the top element in the stack is an open parenthesis, so that means that's a good sign. We just found a valid string. And then, so let's remove that first. And then, so the length of that, so that means at index I, we found this is valid here, and we popped the top element from the stack, but the top of the stack is always a non-valid one, right? So we are storing the index of non-valid. And then we found the open parenthesis, and then we remove that. So we know that everything from the last non-valid till here is valid. So this is the length of the new valid string. And so the length of the new one, length of new valid is equal to the current index, because we know that we have that, minus stack. The index of that last non-valid is the first, so this one. So let's say we want to have an answer as 0, and we always want to keep the maximum of answer and the new one that we found. So answer is the maximum of answer, and for simplicity I want to use this directly to have a cleaner code. Otherwise we just put that on the stack. So stack.append, the format we know that already, so it's I and C. However, initially when we start the iterations, let's say we are given a string with the open and closing parentheses. So we first put this one first on the stack, so it is 0 and an open character on the stack, and then we get this one. So the character is a closing parenthesis, the top element is 0, is an open, so we remove them. This is a valid, but what is the last non-valid? So for that, in order to handle, since we are iterating from index 0, let's put a phony non-valid. The last non-valid is before the string begins. So let's put a -1 or a -1 and a closing parenthesis, so that we make sure that it never pops up from the stack, because it is not valid. And then if we put an open parenthesis, we might see that specific phony element popped after seeing a closing parenthesis. But by putting a closing parenthesis, we know that this is always will be on the stack. So initially, I initialize my stack with -1 and a closing parenthesis. And by that, since we know this is always not valid and our stack is always storing the not valid strings, so this item will be never removed from the stack. So this is unnecessary here. And then we can return the answer. Okay, so it should be fine. Let me try that. Okay, and okay, let's try the first item. And the last example is an empty edge case string. Okay, so let's submit that. Okay, so that was everything for today's problem.